Hi, my name's Sebastian McKenzie. I work on web content optimization at Cloudflare. So I work on making websites faster, monitoring performance, that kind of thing. So what I'm going to be talking to you today about is JavaScript transformation. So what is JavaScript transformation? Well, you put JavaScript in and you get JavaScript out. The generated output is determined by contextual information based on what you put in. So it statically checks and infers kind of what the code does and then transforms it as such into the output JavaScript. So first off, let me explain some history. So there was this new thing called ES6, now ES 2015. There was a large gap, in my knowledge, on parsers, compilers, and generally the intricacies of JavaScript. So I decided to make an ES6 transpiler to learn it, called 6-to-5. Unfortunately, this wasn't a very good name. People started to use it, and 6-to-5 already supported bleeding edge ES7 stuff. So it would have required a name change to 7-to-5. And then once ES6 became mainstream, it would have had to be changed to 7-to-6. But then ES6 was renamed to ES 2015. So this obviously wouldn't have been very practical. So in order to keep up with the rapid pace of the web, the name was changed to Babel. With this name change, not only came the sense of permanence where future versions would be supported, but the scope of the project was kind of expanded to be a more general JavaScript compiler. I'll go into a bit more detail on what that actually means. But basically, different types of tools could be built on top of Babel, and they'd be future-proof. So what does that mean? So for example, if you built a minifier on top of Babel, and some cool new ES feature came out, as long as Babel supported it, everything that was built on it or used it would support it too. So to give some context on why this is neat, you need to kind of understand a bit about how it works. So you have some source code. Cool. How are you going to deal with this? Would you throw a regex at it? No, not really. There are way too many variations of syntax in order to kind of do anything good with just regular expressions. So you need to represent this code in a data structure that you can deal with, called an abstract syntax tree, or AST for short. So this is the AST for the previous code. It's a group of deeply nested objects that expressively define each syntactic element. So each property of these nodes contains metadata about what it represents. So this may kind of seem intimidating, but an easy way to visualize this is via a tree. So it is the T in AST after all. So as I said before, each syntactic element represents a node. So now that you've got some context on what an AST is, it's the data structure that we deal with when we're dealing with code. It's easier to understand each component of Babel. So they're split up into three very distinct areas. So you have the parser that turns your raw code into an AST, which then parses it to the transformer to manipulate, then onto the generator to turn back into code that you can execute. And so this graph is more to scale about where most of the time in Babel is spent, and where the smarts and kind of logic actually is. So the transformer layer is mostly where the tricky stuff happens, and in order to understand the core concept of the transformer is to understand traversal. So traversal is where you have a tree represented by the red nodes, and then you have a visitor represented by the blue node, and you want to visit all these nodes. So basically it happened like this. So you would visit the program, the variable declaration, and then you'd keep on continuing through the entire tree. And at any point, additional nodes could pop into existence or nodes could be deleted. And this can be tricky, so if you're replacing a set of valid nodes with a set of invalid nodes. So to make kind of this a bit easier, Babel is aware of JavaScript semantics, so it can understand what JavaScript means. So what does this kind of mean? So here's an example. Here you've got an array destructuring assignment. This should execute calculate coordinates and assign the values of x and y to the 0 and 1 index of the result of the function call. So this would look something like this. So yeah, this works. It's in a statement position, but what if we use the exact same transformer on an expression? So this should do the same as before, but the resulting value should be the right-hand side, so it should be the result of calculate coordinates. So if you use the exact same transformer on that code, it would output this, which is obviously invalid. You're trying to replace an expression with a list of statements. And what does this even mean? So JavaScript's statements and expressions are different things. But in Babel, they're kind of equivalent. So it can tell kind of what you're doing and explode that into this. So that's the exact same transformer so it's written only for one context, and it can support many just based on inferring information about it. And one of the other things that so replacement is one of the things you find yourself doing to the tree, and the other is removal. So here we have left plus right is represented by a binary expression, and say you want to remove the right node. So typically you'd get something like this. So you just have left and it's missing a right node. This is invalid, and so Babel can tell, oh, hey, there's no right-hand side, so it just replaces it with this. So it's kind of powerful so that you just write it for one context and the internals kind of handle it for you. So it reduces a lot of bugs where you're not repeating constantly each specific scenario that something can appear in. And so there's a lot of applications for this. It's extremely wide, from browser compatibility to module mocking to profiling, so it's more or less the same thing. JavaScript in and JavaScript out. So today I'm going to be focusing on 4 different areas: transpilation, so ES 2015 to ES5, application optimization, browser compatibility, and a mystery use case, which is by and large my favorite. So first and foremost is transpilation. So there's this new fancy thing called ES 2015. It adds a ton of new features, from arrow functions to tail calls. Unfortunately, browser support is fairly poor. I mean, it's entirely new standard. These features are incredibly complicated to implement in modern engines, and even when modern browsers do support the whole range of features, there's always going to be the mosaics of the world, and more importantly, mobile browsers that rarely get updated. In an accessible and open web, it seems ridiculous to kind of limit yourself to the latest and greatest browsers. And so one of these new fancy features is ES 2015 arrow functions. So these are a different way to write functions. I've picked this feature specifically because it's seemingly straightforward how to transpile this, but there are kind of some hidden gotchas associated with it where it's not perfect. So these are the 4 kind of main semantics of arrow functions. It has an implicit return for expression bodies, it inherits the arguments and this bindings, you cannot new it, and it has no prototype. So for this example, it turns var multiple just into a return. At this stage, it's just kind of just syntax candy almost around it. So yes, we can do implicit return for expression bodies. But what about arguments in this? Well, so we've got this. It's meant to reference Bob, but if it was just a normal function, it would reference this.friends. So in order to retain the same this binding, you can just simply add a reference to this, and then replace this in inner functions to reference that temporary variable. So we can inherit the arguments in this bindings. But now for the bad news. What about not being able to new it? So in ES 2015, this should be illegal. Arrow functions aren't completely synonymous with normal functions. I mean, if it was, there wouldn't really be much excuse to have it in the language. And since we're just turning arrow functions into normal functions, it works. So one of the ways we could do this is by adding a name to the function, so _arrow, and then replacing all new expressions with this helper method that checks to see if the name of the function is _arrow. But what if you're relying on the name of an arrow function? So foo.name should be foo, not _arrow. So you're trying to implement specific semantics by introducing bad ones as well. So it's kind of, or you could add a property and just use that. And then in the construct helper, check to see if it has the _arrow property. It's kind of crap. So in the first example, we're adding the wrong name to the function, and in the second, we added a property. Even if this was practical, it only really affects code that we've compiled. So all third-party code that would execute it, it would work normally. So it's kind of iffy. We can't completely replicate, at least not practically, some of these features and semantics. So we can't not allow people to know it, at least not practically. But what about no prototype? So as I said before, array functions aren't normal functions. So they have no prototype, so you can't use them as constructors. So since we just turn them into normal functions, how could we get the same behavior? So we need some way to mark it as an array function. In this case, we add a property, and then we change all references to just .prototype to use this helper method that checks to see if it's a function. If it is, return undefined, otherwise just return the prototype. But this is problematic since JavaScript's a dynamic language, so it could be like this. It's kind of difficult to catch, so this means that you would have to wrap every single property access, computed property access to determine whether or not it's ever going to access a prototype. So you'd end up with something like this. It's going to add a lot of additional overhead, especially in hot code where performance is extremely critical. It's not really ideal. You're re-implementing a lot of native JavaScript features that are kind of unnecessary. So this is even worse. It means wrapping all code that we think is dynamic with helpers. So at this point, we're like the little engine that could. You can almost get there. You're so close, but there are some things that you can't really practically implement using just ES5, especially if you want really good performance. So what does this mean for the average developer that's currently transpiling? What would the migration path be like from transpiled ES6 to normal ES6? It'll likely be smooth, but like if you're relying on some of these unspecified semantics that the transpiler will kind of destroy, then you're likely to run into issues. But it's better than nothing. And so following this, I kind of want to emphasize this point, where you shouldn't be using transpilers to learn new language features. You can definitely compare the output, but if you're just basing all of your knowledge on new language features on, hey, this is equivalent in ES5, so it's exactly the same, then you're likely going to be misinformed since there's a lot of hidden semantics that can't properly be replicated. And so even stuff like referencing a variable can drastically change the way that the code is generated. And so, yeah, it's really contextual, so you shouldn't really be relying on transpilers to learn new language features. So what about something a little more practical? Application optimization. At face value, this may seem like an absurd claim, but allow me to elaborate. So to preface this, I'll have to talk about compile time versus runtime. So when you're compiling your code, so at compile time, so when you're compiling your code, it hasn't even been executed yet. And runtime is when your code is actually running, so when it's executing. And you simply know different things at different times. So when you're compiling the code, you can determine that square is called with a to-literal, and then square is called again with just a variable. At runtime, you can't determine, the square function can't determine what it's being called with, since it only cares about the actual value, not kind of where it came from or how it was represented. So this is extremely useful, so we can determine what the exact intent of the code was. So what are some examples of this? So a big one is React. You may have heard of it. It has a neat feature, JSX, which is an XML-like syntax. You either love it or hate it. It is, however, good for one thing, which is providing additional language semantics. Now, traditionally, it's really just been syntax candy, so it's been like a one-to-one mapping to function calls. But in React 0.14, JSX elements are treated as constant value types. So if it looks the same, then it'll always return the same value. So whenever you call render, it will return the exact same instance. So this is extremely important for performance. It's why you're constantly doing more work than you have to. So this would be turned into something like this. So it'd be hoisted to the highest scope that it could, and then just return foo would be done in the render method. So each time you called render, it would return the same element. So this works for immutable elements, but this can also be applied to mutable ones as well. So here, the JSX element references the foo and text variables, and so that can be hoisted to the create component function, like so. And so the core concept is just pre-processing and making the JavaScript engine do less. since doing less is generally faster and JavaScript engines have no way to infer this kind of behavior. You have to tell it, basically using this kind of techniques. Another example is Ember. So Ember uses HTML bars. Now you may want to use these embedded in files in stuff like tests. It seems silly to have to constantly compile this every single time the code is run, since this is static and it's constant, so there's no reason to really be making the client do it each and every time. So you should be doing it when you're processing, when you're building your JavaScript. And so you can determine that tagged the template and then compile it when you're pre-processing it into something like that, where the comment represents the actual template contents. So there are the main points that I want to take away from this. You shouldn't be relying on pre-processing for functionality, so this type of stuff should purely be supplementary instead of additive. So it shouldn't really be changing the way that the code works. It should just be making it faster or removing things that kind of don't matter, since your code may not care about it. And you're the only one who can make assumptions about your code. The JavaScript engine can't be more lenient. It can't not do things. If you tell it to do something, it has to do it, so you have to tell it to do less. So the next item is browser compatibility. Basically, it's just trying to patch broken browser implementations of certain features. So this isn't relevant really in newer browsers, but there are some things that in older browsers that are just completely broken. So Internet Explorer 8, who would have thought this would have been one of the browsers that was broken? So there's an issue with named function expressions. So here we declare a variable with a function expression. Note that it is named, and then on line 2 that it's leaking out, so it's kind of being treated as a function declaration. And then on line 3, it's creating 2 different bindings with 2 different objects. What? So what's the solution? You automate it, you fix it. So this is a Babel plugin that will change all named function expressions into an immediately invoked function that turns the function into a declaration and then returns that declaration. So this may sound more complicated than it actually is, but this is basically what it does. It turns the named function expression into this immediately invoked function that turns into a function declaration and then returns that function declaration. So that basically fixes the buggy behavior of Internet Explorer 8. So the last mystery application of JavaScript transformation is Emojification. I have no idea if that's an actual word, but I think it is now. So ES 2015, it has Unicode point escapes. So you can do stuff like this, where the variable declarator ID is a Unicode character. So what does this really mean? Emojis. So we've got this boring code. I took this from the jQuery source. There's too many letters. Kind of what can we do with this? So we can convert this to this. Now, here all the identifiers are escaped, but have no fear, they do represent emoji. So unescaped, it looks like this. Beautiful. So you don't even need comments at this stage. You can just represent the intent of your variables using emoji. So how can you do this? Well, I made an npm package. You can install it and use it. Probably won't run in browsers since not many support, or I'm not sure if there are any that support Unicode point escapes for identifiers yet, but the future. So JavaScript transformation, JavaScript in, JavaScript out. Hopefully by now there's a lot of potential for extremely high quality tooling that not only evolves quickly but is very stable, that keeps up the rapid pace of the web and as new features are implemented. Yeah, so that's it. Thank you very much.